Welcome back to the unit on linear relationships. In today's lesson, we will build on yesterday's introduction and do some more work with linear relationships. The goals of today's lesson are that you can interpret the vertical intercept and the slope of a graph in a real-world situation, and that you can match graphs to verbal descriptions by identifying the slope and the vertical intercept. So here we have an example of Julie with $15 in her piggy bank on New Year's Day. And she decided, which is the first day of the year, and she decided to start saving some money each month in the new year. And she recorded her monthly savings in the table below. So at the end of January, she had $25. And remember that at the beginning of January, she had 15. So I'm just going to note that here, at the beginning of January, $15. So that's an increase of $10. And then at the end of February, her savings grew from $25 to $35. So that's another $10 savings. And she did that every month. She saved $10 per month. So we're asked to graph this. I've graphed it to save some time, and let's talk through the graph. So here on the, before any month has passed, she will start off here, has counted the money in her piggy bank on the very first of the year, and she has $15. And so that will be the first point. And then after 1 month, which will be at the end of January, she has $25. At the end of the second month, at the end of February, she had $35. I'm taking these from the graph, or from the table, and you can graph your line then through the points. The vertical intercept is this point here. It's the point where the line representing the situation meets the y-axis. It's called the vertical intercept. Sometimes you'll see it called the y-intercept as well. And in this case, the coordinates for it are 0 on the x-axis and 15 on the y-axis. And in this context, it means her beginning savings, her beginning amount of money in her piggy bank. So I'm just going to say beginning savings. And the slope then is how much it's changing every month. So from 0 to 1, it increased by 10, went from 15 to 25. And then in the next month, it went from 25 to 35. So the slope is 10 over 1, or just 10. And in this context, it means how much she is saving each month. So let's look at another example and look at the context of the y-intercept and the slope. So Jonathan is reading a book, and he decided to start graphing the pages, the number of pages he has read after so many days. I guess he's keeping track of how much he's reading. And so the y-intercept, when he starts graphing, is, I'm just roughly drawing it here. It's going to be 0, 25. And remember, y-intercept is sometimes also called the vertical intercept. But here's the y-intercept, and the slope is 20. So your line goes from there. Let's say that's 25. So 20 would be here. And let's say this is 1, 2, 3. So after 1 day and after 2 days, he'd be up here somewhere. Just to roughly draw it. So this is his slope, which is the vertical over the horizontal changes, and it's 20. So the y-intercept 0, 25, question 1 here, means the beginning number of pages. Beginning number of pages. And then the slope, number 2, means the number of pages per day that he's reading now. So to summarize, the y-intercept, which is also called the vertical intercept, represents the quantity at the beginning before any change. When you start graphing, if you have some savings already, you've already read some pages or whatever it is you're measuring, you graph that at the y-intercept. And then the slope represents the rate of change, or the constant of proportionality. How much you're saving every month, how much you're reading every day depends on what your x-axis represents. But the rate of change is represented by the slope. So in today's lesson you saw a vertical intercept and a graph, and you could match a graph to a real life situation by looking at the slope and the vertical intercept. And that's the end of today's lesson.